First, let me apologize, feeling a little under the weather here, but the best way to get over colds, obviously, is to get in your garage in the winter and build stuff. So when I first set this up, I was thinking that the generator I would rarely use, and the truth is I probably would rarely use it, but when we do use it, we need it for days. So all I have for backup is a small 2000 watt generator that runs regular household 120 volts into a 48 volt charger that comes down, feeds the battery so the inverter can kick it back up to AC and shoot it out. Super easy to set up, but really inefficient because you're going from the generator that needs its own inverter to bring it up to 120 into this to step it down to 48 volts DC into the batteries at 48 volts to step back up to 120 AC out to the house. So by the time you're done, you're wasting a ton of energy and not really getting much out of it. So I wanted to buy a 48 volt generator for solar backup. Then I went to see how much those things cost and said, no, we're not doing that. So naturally my next thought was, well, how much is a 48 volt alternator, and is that even a thing? That's a thing. But again, went and looked at the prices on that and said, that's not my thing. So as usual, I had to kind of trial and error my way through this and try to figure out a way where I could get what I wanted and not spend $3,000 to get there. So got an idea. So in order to do this, we're going to need some sort of engine. Oh, that works. So that's got to connect to something that's going to make 48 volts. All right, we got to be able to connect these together somehow. Wow, this thing's going to be pretty heavy. I don't know how I'm going to move it. Well, hell, I think we got everything we need to cobble up a half-ass 48 volt DC solar battery generator. So first we needed an engine of some sort, and I knew I wanted about 100 amps of output at 48 volts. And then the rough math on that from a horsepower calculation is about every 750 watts costs you about a horsepower. So I probably could have got away with like a small little 3-horse, but these guys are so cheap. This is the Predator 212. It's like 7.5 horsepower. You see them in everything from snowblowers to wood chippers to ladies' toys. And they run great, and they're super efficient on fuel and super cheap. For the power side of things, the 48 volt alternators are rare and very expensive. However, 24 volt alternators that you'll see in heavy equipment that run 24 volt systems are very cheap. So what we have here are two 100 amp 24 volt DC alternators. So we will wire these guys up in series to get 48 volts at 100 amps out of the pair of them for way less than the 48 volt counterpart. A little bit more work to set it up initially, but when I say way less, I mean like 1/7 the price. So that's huge. Got a pulley for the engine. So I pretty much matched this with the pulley that is on the alternators, because this will rev out at like 3,600 RPM. You start making really good power at about 2,500 on a regular alternator. These, I bet you make power even lower because they're meant for a diesel application. So we only need to rev this thing probably around 2,000 RPM, which will save a lot in fuel, keep this thing out of the high rev range, and keep everything cool using a kind of a 1-to-1 basically pulley setup. I got two idler pulleys because of the belt routing. We want to make sure we're capturing, enough around these pulleys and the engine pulley to make sure we don't have slippage issues. So I'm thinking we'll just pinch it in the middle with these two pulleys. And then I got some nice casters to roll around whatever this thing ends up looking like. And usually at this point in a project, I know exactly what I'm building in my head. I've got it figured out. This one, I don't know what it's gonna look like. But I figure it's gonna be heavy anyway, so we're gonna have to put wheels under whatever it ends up being. Shit, we'll go from there. By the way, to Harbor Freight, Predator, I don't know if that's the best name you can slap on things. I'm just expecting that I open this box and Chris Hansen's gonna come out and tell me to take a seat over there. Just thought. That's a strong bag. I seriously don't understand how these little kids in China can build this for 150 bucks. It's just amazing. All right, moment of truth. Does our pulley and our key fit our engine? Yeah, buddy. All right, so what do we know so far? We need a base of some sort. And I think we're gonna build our base this way, but let's see how big those alternators are before we get too crazy. Whoo, those are not small. And I believe this is a counter rotation from this shaft. So we can't just slap these guys over here and run a pulley around it. It's gonna spin the alternator backwards. So the easiest way to kind of get around that is running your alternators opposite the direction of your engine. So when this spins this way, it's actually spinning this the other. So we're gonna figure out something, somehow, some way that does that. Let's start mocking up a little rail chassis here to set all this crap on, and we'll keep taking it one move at a time. So just slap together some 2x3, ironically off the solar trailers, and we'll use that as our base. Now we just gotta kind of figure out mounting wise. Leave myself enough room here because I may enclose this at some point. I don't really know. Again, I don't know what this thing looks like. I'm just kind of building it as we go. Oh, just barely. So I plan on welding these in as studs, but before I do that, I want to run some nuts down these to hold them in place so we can test fit and make sure all the measurements are right. Because that would kind of suck if they were wrong. Not that I ever make mistakes or anything. Like a glove? For a little bit of vibration mitigation, I'm gonna set these guys on some grommets. Oh, that's beautiful. Yep. And then we'll just get a washer to squish those. It probably makes the most sense to somehow link these guys at a reference point like hinge. Nah, that doesn't work. So if we just made a low pivot, man, that'd make for a really small belt. Yeah, see, I don't think I give enough pulley. Well, let's figure out our setbacks, I guess. We'll start with that. All right, so that clears the end, the muffler. Here's what I'm thinking. So we gotta get tension around these things, right? So I tie in both mounts on the alternator there. I put in my pulley here, so the belt route will come off the engine, around this pulley, back down around this pulley, back to the engine. So that way the engine's got great grip, these guys have fantastic grip, and this happens to tie these together nicely, and I can still rotate one or both to adjust the tension on the belt. This builds it a little bit taller than I was hoping, but we'll see. It may not be that bad once we get it all packaged up here. So let me turn this bracket into something we can use first. All right, so we mocked this one up. So we'll take the nuts off the back of this guy, bolt it into our new piece and see if that works. Alternator. Plate. Ah, Christ's sakes. Yeah, got a little weld splatter in the holes. That was what was fighting me. Last thing I've got to do here is just put the set screw back in fully. We've got it aligned close enough. What I'm doing here, this is just going to be a test firing. Obviously I got to pull everything back apart if it all works and paint it up, make it look nice, and lock tight some of these connections. But I just right now want to fire this thing up, hopefully, and test our output voltages here and see if we've made ourselves a generator. So ignition's on, choke is on, gas is on. Get out of here. These engines are sweet. Already trying to fire. A little more throttle. A, the engine ran. B, none of my shit went flying everywhere. So, I mean, we're already doing better than expected here. This is awesome. Wow, that worked way too good. So we got 29 volts, unloaded out of both alternators. So together unloaded will be just under 60 volts. And it likes to pirouette. So we're gonna have to get the casters under there. The casters I bought all have locks on them too, so it won't be dancing. But it's nice to know if we wanna leave it unlocked, we can just let it randomly dance around the floor. But holy crap, that actually looks like something a Not Idiot built. And that's always my goal. There's a reason I named this channel what I named this channel, and this is a perfect example of that, where running into a problem now that we have it assembled and I went to go hook it up and use it that I didn't even think about when I was laying this process out. So let me explain to you the problem. So we have two 24-volt alternators here that, when wired in series, would produce 48 volts. The problem is, these are negative ground units, and in order to excite both of these, they need to both see a ground. And you can't tie the positive, which is all we try to do here, into the negative of this one to make that loop, because this one is going to not excite the coil at that point and not produce any power. And then if you do try to connect them, they're basically fighting each other and one will shut off. So this is a good theory, but in reality, with the way alternators create current from AC into DC, there's no real way to make this work as is. So unfortunately, that means I have to rip apart these alternators and make another attempt at completely rewiring them, utilizing the AC fields off of these, exciting the coils with a DC, and seeing if we can rectify that into 48 volts. And that's gonna suck. Here's where I think we're at, and what I think part 2 of this video, which is now a series, is going to be. I gotta wait on some parts, obviously. I wasn't planning on doing this. So there will be a second video of me making a second attempt at a second way of failing on this setup. But little bit of background on alternators. I know they seem complicated to some, but they're really simple and complicated at the same time. So what we have going on here is there's two brushes here, just like you would see in a DC motor, and those two brushes control the voltage that goes to the coil on your rotor here. And what that does is, based on the voltage going to that coil, it determines how big the little eddy currents are that are flowing through this system, which interact obviously with your larger 3-phase AC coil on the outside. So by doing that, that's how it regulates its output no matter what RPM this thing is spinning at, because it can reduce the power going, the DC power going here, to reduce the eddy current so that they don't create as much voltage, or it can increase those if it needs to in order to match the output voltage.
Main winding was of the normal Lotus O deltoid type, placed in panendermic semi-boloid slots of the stator. Every 7th conductor being connected by a non-reversible Tremie pipe to the differential girdle spring on the up end of the gram meters.
So this is the coil that actually creates the output current, and you'll see that it comes out in 3-phase, and that's AC. And what that is going into is a bridge rectifier. From the bridge rectifier, that creates the, in this case, 12 volt or 24 volt DC output, and that's really all there is to it. So this bridge rectifier isn't smart. It's whatever voltage is coming in from AC, it's going to put out the same voltage basically in DC. So that's why it utilizes the eddy currents by adjusting the voltage going to the rotor to adjust the overall output. So we've got a couple of different options here. One, we can try to mess around with figuring out how we can adjust this voltage and see if we can get her up to 48 volts and turn these into 48 volt alternators as is. Other option is to pull all of this out of here, connect 3 wires to this, put our own external bridge rectifier on there, and a DC source that supplies voltage to the coils that we can adjust to dial it in. I don't know which way we're gonna go with that yet, because I didn't expect to have this problem, but that's what I'm gonna be working on between now and the next video. As always, guys, I appreciate you watching, the good, the bad, and the ugly. Good news is all the mechanical stuff works, so that was actually my bigger worry. Turns out I wasn't even thinking of the whole series parallel rectifier, and yeah, you know, sometimes in life you're the foot and sometimes you're the ass. So I'm the ass. Thanks for watching, have a great day, and I'll see you soon.